Welcome to Mind Bending Monday. Thank you so much for joining us today. We appreciate your time. Today is the second episode of Visual Puzzles, and today's topic is how many squares. You've probably seen these puzzles going around the next door or social media, lots of different places, and even adults struggle to solve these puzzles. So we're going to look at some visual strategies for solving them. And if you teach algebra, you're in for a special treat. Did you know that your students can derive a formula that will work with any size square? It's pretty exciting. Are you ready? Let's get started. Visual Puzzles, Episode 2. How many squares? These puzzles are wonderful, and although their history is unclear, you can find these puzzles everywhere. I often see them on social media or next door. But we know as teachers that visual thinking skills are so important. They affect so many areas of life, not just mathematics. These types of puzzles are a fun and engaging way to build these skills. And as a bonus, if you teach middle school, your students can derive a formula for finding the number of squares in this basic model, no matter what the size. So we'll talk about that too today. You have probably seen this before, but today we are going over just a basic way to organize so that students can solve this mathematically and really build those visual thinking skills. Are you ready? Let's get started. How many squares are in this picture? If you want to stop and solve this, now is the time to do that. When you give this to students, you will have a variety of answers. And as you have different answers, that's a great time to question. What is the greatest challenge in counting all the squares? All the squares you are counting are squares, but is there any other way you can sort them? How? And would that help you? Why or why not? As students struggle with this and as they share things that they see and don't see, some students might start to realize that the squares are different sizes and that more than one square can be combined. So, how would you organize that type of thinking? Well, you wouldn't tell students this right away, but you can say, what's the smallest square that you see? What's the largest square that you see? Do you see other sizes in between? And as they brainstorm, they might discover, okay, well, you really have a 1 by 1, 2 by 2, 3 by 3, 4 by 4. And if you've come to this conclusion, this is a good time to stop and let them struggle again. How many squares? You don't want to tell them the answer, but you can scaffold by giving them an opportunity to think, then asking questions, organize your thinking, and then let them try it again. Assuming you've done that, let's look at the solution. How many 1 by 1 squares is pretty straightforward. Most students can easily see you have 4 columns and 4 rows, so there are 16. It's when you get to 2 by 2 that it tends to be challenging. So give students an opportunity to look at just 2 by 2, and most of them will see immediately these 4. But are there other combinations? And this is where think time is really important, but it's also important to organize your thoughts. So you might just want to scaffold by saying, what if you only considered these 2 top rows? How many 2 by 2 squares can you see? Well, if you start here and then just slide it over 1, there's another one. And slide it over 2. So there's 3 right there. But some students will skip right here, but do you have to do that? So if you were making an organized pattern, what would you do next? And give them time to see, well, you could just move down 1 because there you have another one. And in this row, there are also 3. and then move down 1. And in this row, there are also 3. So you have 3 rows and 3 columns. So in this, you actually have 9 squares that are 2 by 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's look at the next size. How many 3 by 3 squares? Okay, so this does become a little easier because in this row you only have 2. And then you can move down 1 and you only have 2. And that's as much as you can move with that size. So you have 4. 1, 2, 3, 4. Okay, the largest one is the easiest. There's only one that is that size. So if you keep that in mind and you add them together, you have 30 squares. Great job. How can you apply that pattern to find the number of squares in any size grid? Let's just call it n by n. And can you prove why this is true? So in middle school, give your students time to really reflect on this. This is challenging. Give them think time. If they're stuck, you might want to talk about exponents. These are squares. So what if we write our answers in exponential form? What do you notice? Well, we knew that we were finding 4 by 4, 3 by 3, 2 by 2. So it makes sense that we're writing this in exponential form. But what about this? What about our answers in exponential form? How many squares would be in a 5 by 5 grid? Give students some time to explore. If you teach middle school, you may already have your square size written in exponential form. We wanted to make this accessible to elementary students also, so we've written it this way. So if students are stuck, maybe they can explore doing that with 5 by 5, a 5 by 5 grid. What do they notice? And what if you had an 8 by 8 grid? Hopefully they are seeing patterns with the size and the quantity. So give them time to explore. They will get it. It's pretty exciting. So you could say, what would an n by n be? Well, eventually they'll come up with this formula. 1 squared plus 2 squared plus 3 squared plus 4 squared, all the way to n squared. But why is that true? So even if they see that pattern here, 1 squared, 2 squared, 3 squared, 4 squared, but why? Why is that true? Have them really think about the relationship between n and the size of the squares and the number of that size. So let's think about it. In an n by n square, you have one large square that's the size of that square. If you take this and you make your square size one smaller, n minus 1, you're always going to have 4. If you make it 2 smaller, you're always going to have 1, 2, 3, 4, 5, 6, a 3 by 3. If you make it 3 smaller than n, then you're always going to have 4 by 4. That will continue until you reach the smallest square, which is 1 by 1, and then the number of squares that you will have will be n times n. Isn't that amazing? Do you want to try a more challenging puzzle? Try this one. I found this one in Mental Floss magazine. Which would help you more in solving this type of puzzle? The visual strategy we discussed at the beginning, or the formula, or maybe both? Why? I challenge you to solve this puzzle this week and have fun. We will have a detailed solution available for you next week on our website. If you love these puzzles as much as I do, you're in luck. They are everywhere. All you have to do is go online and you will find more than you could ever want or use. So have fun. Thank you so much for your time. We really value your time and we really value your opinion. So much so we're giving away free prizes every month. So if you try this type of puzzle, please use one of the ways below or more than one to enter to win a free prize. Also, don't forget to hit like and subscribe. We don't want you to miss a single week of Mind Bending Monday. Thanks so much. Have a great week, and we'll see you next Monday.